All right. So we might as well get started. Welcome back to the channel. If you've been enjoying what you've been seeing, please like and subscribe. It really helps us a lot and provides encouragement for us to keep moving and keep doing this and to want to do more videos. So we left off in the last video stream working on routing the PCB traces for the stepper motor driver chip, and a couple major connections to make still. Ran into the wall where couldn't drop a via in to go down to the current sense resistors. I was thinking about changing the size, the thicknesses of these traces to allow for that. But then looking at this, another solution came to mind. So this way we could maintain the larger power traces for the stepper motor and not have to risk any integrity or compromise anything. We're going to do this a different way. So these we're going to change. These two, pretty much not anything can be done about. But this guy, violates DRC. I really don't care right now. Oh, you're kind of too big on this guy, huh? Too big on this. So let's see, what size are you? 0.39. 4. Let's go drop you down there. May have to we'll solve that problem as we get to it. Yeah, it's just upset because it's really close to these guys, but we already have that minimum gap here, so we already know it's not going to hurt. Okay, control click. All right, so what we're going to do, get rid of that, leave that little stubby guy right there. All right. So what we're going to do, let's bring this back a little further. Oh. You bring this back a little further. Okay, so what we'll do then is let's go to the bottom copper. Hello. All right. Let's make sure we got okay, we're good there. We can leave the text there. That shouldn't be a problem. Okay. So we're going to come back up to the top copper, and we're going to pull a trace off of you. And drop you to the bottom copper. Let's make sure that actually, nope, it did not route. All right. Top copper. And what we're going to do is we're going to bottom copper. All right. So we're going to kind of beef you up. Beef these guys up. Bottom. Shouldn't be a lot of current, but I don't want to take chances. We'll take care of the ground connection here in a minute. Let's get the main power. All right, that allowed us to drop in the vias and go to the current sense resistors. Yeah, there might be violations. Space between tracks might be too narrow here. Won't be, I mean, technically won't really be too much of a problem because, you know, we already have a space, you know, the distance here is already pretty narrow. So it should be fine. So let's go to the bottom layer. So we're going to solve this ground, but first I'm going to throw in a ground port underneath of the driver chip. That way these vias can tie to it and it'll give another good path for dropping heat. Ground. So not only will we have active cooling, we'll also have a good copper pour underneath of the IC. All right, good copper pour underneath the IC. That'll help pull heat out of it as well through the exposed pad. So let's go ahead and now drop these guys over to those vias. I mean, technically we don't need to worry about the connection points at the via because it's going to intersect the copper pour and it really doesn't matter. So that takes care of that guy. I also noticed up here, we didn't grab this guy off the voltage divider up there. All right, so we got that connected. All right, all the majors over here connected. All we really have are the basic signal logic, 3v3 and all that, which we will take care of. Normally I'd pull that to a copper pour, but it's not really used to actually really power too much on this chip. It's mainly just for the basic logic. You know what? Let's go ahead and do that. Wouldn't hurt to follow the same design practice we've been following for everything else. Let's just do it right. I'm going to pull it away from the other logic pins. We'll clean up its shape once the vias get thrown in there. Not terribly where it's just a rough draft right now anyway. Fill it in. We're going to go ahead and all right. Grab a via. We can always rename those. So let's go ahead and tie that to 3v3. Let's go ahead and All right. So that'll give this guy a good, I mean, as good as a connection to 3.3 volts as possible for the logic. And that'll give us enough routing distance so we can tie in the step. If we have more room, we'll snug this closer to the IC. So we'll take care of that later. Not terribly worried about. We're just trying to get all the rough framework wired in, ready to rock and roll. We'll worry about all the signals here in a little bit. All right. To this guy. Oh, okay. So this is the terminating resistor, it looks like. All right. Let's see here. So we kind of got those guys set up. So let's go do some routing. Okay. We'll see if that gets us any design errors. But it shouldn't. All right. Okay. All right. So what we can do here, all right. Okay, looks like that's good. That's good. Looks like we got a lot of the preliminary stuff set up. Up. That's just for the termination resistor. I'm not going to obsess over those small little details. It's not worth it. A little bit more robust. Okay. Considering it's a TBS diode. How much of a pain in the butt would it be to reconfigure it? Put the ground over here on this side. So we can give that ground a good ground pour. You know what? Let's do that. Let's clean this up. Let's do it the right way. Let's do that. Let's see here. Let's see about getting some of these other guys routed. All right. Like this. That up. You know what? The easiest thing to do? Let's just do a V up. The top layer. All right. Now to give this guy the attention that it deserves. Let's nail that. Round. Oh, I must have not grabbed it right. And we'll resize it once we have it. There we go. Let's grab one of these little vias. A little bit bigger. All right, there we go. Nice ground connections for this guy. So we have a nice solid connection into the ground plane. So this is a TVS diode. All right. Let's get back over to here to this little fella. So we're gonna have some splash over, but let's go ahead and get another ground pour for this connection. Again, we'll resize it, clean it up. Let's just get the initial frame. Next, all right. All right. So I need to change some options on these guys. Okay, I forgot. Wrong thing. I need to change the options on this guy. Thermally solid. B. Boom. Go back over to this guy and do the same thing. Thermally solid. Boom. All right. So nice ground pours. Make sure this guy solid. Boom. Just make sure everything's consistent. All right. Okay. Now we have our 5 volts. You know what, let's go ahead and tie all that together. Right. We will worry about tying all that together here in a bit, because it's got to come from over here, the 5-volt rail. Depending, I'm not 100% sure I want to bring it over. I could just throw a trace on the bottom, because I don't have an internal plane. There's only a couple things that pulls off the 5-volt, so it almost doesn't matter. So I'm not going to terribly worry about that this minute. I want to kind of get some of these other guys pushed together properly. Let's go and get a big ground connection for all these guys. Start. Ground. Here. Ugh. All right there. Okay, it'll avoid that. Throw some ground vias in there. Throw an additional one. All right. So it takes care of that guy, the ground connection. Okay, let's see if we can pull that out a little bit more. Yeah, there we go. Perfect, perfect, perfect. All right, so we have that guy. All right. You know what? We probably should worry about the 5-volt. So don't cause a problem that we can't fix later. I'm gonna do this. Let's see here. So I could run a trace on the bottom, or I could just use one of the inner layers. So one of the things I try to do is determine, try to stay consistent with the primary routing direction of layers. Like choose like a layer to go north to south predominantly and a layer to go east to west predominantly. So I kind of started internal signal layer 2, which would be underneath the power plane, to be north to south. So we'll go this layer to be east to west. So the predominant routing direction of this guy would be east to west. So that's what we're going to do. So what I'm going to do is we're going to give ourselves just a little bit more room. I'm going to throw a nice big via in there. Change that to 5 volts. So one of the things we want to ensure is robustness on our power lines. So it'll be, this guy will be east to west. So remember, we got a power plane, ground plane, and then our two inner signal layers. So we're going to choose this guy to be predominant east to west. So one of the things we can do is just run a really, really big trace. And let's tie these guys together. Go ahead and make that a little bit bigger. 0.4. Will we need a trace with that much current running carrying capability? Probably not. But it's just a habit I've gotten into with running things like this. So we'll go back to the bottom. And let's get this area. All right, fill that. You also don't want to stack your vias on top of each other because you have to worry about drill to copper. Even though they're on the same net, you still don't want to have any problems where manual drilling could cause an issue on the board itself. That should be fine. There we go. That looks better. So now let's go back to inner signal layer, back up to our power supply. And let's just kind of get some routing. So it should carry the like I said, the predominant direction is east to west. All right, so there's the 5 volt for that. So that gets us that 5 volt to that guy. And when we're ready to plumb up the 5 volts for the fan connector, we'll just kind of, we may pull off of this as a bus. We'll figure it out how we want to do it. We're not at that point yet, so I'm not terribly worried about that. We'll take care of that later. So then predominantly, we'll go back to the bottom. It signals now that we've got a route to the ESP32. We'll do that here in a little bit. Here's where things are going to get interesting for the okay, the USB connector and the other serving components around it. All right, so let's see what we have to work with. 3v3, so B bus. Set B, which is fine. It's just a pull up. All right. Let's just go ahead and just start kind of since nothing's really used on those other pins around it, I'm just going to kind of come down here, put the via in right there, and we should be good to go. So that connects that guy together. Here's the V bus connection at 3.3 volts. Yeah, this is gonna be kind of nasty here. I'm already seeing some contentious points, but we might be able to do it. R18. That's not really okay, so we're not really pulling a lot of power off the V bus. I almost kind of forgot about that. So we're not pulling a whole lot of current off the V bus. It's only going to be used so we're not powering the chip off of it. It's only so the UART bridge chip knows that it's actually tied to the USB port. And that's all it's going to be used for. So it's almost we're not going to be pulling a lot of current. It's just a voltage detect circuit basically. We're going to be powering the UART chip from the actual 3.3 volt supply. So we're not looking at anything extremely intensive on that. So I'm not going to overstress myself on that. So what we're going to do then is go to the bottom. Come up. Tie all these guys together. Hello. All right. Tie these guys together. So now those guys are tied together. All right. All right. So we're going to come to the top. All right. All right. Okay. Go to the bottom. Make sure that connected. Yes, it did. All right. Okay. That's fine. Bottom copper. Mm-hmm. All right. Let's see here. Let's go ahead and get the 3.3 volt tied in here, then we'll worry about that. So what we'll do is a pour. We'll have to probably move this via, which is fine. We'll find a new home for it, move it out of the way. We want to move those too much further away from the chip. So let's just kind of start here, 3v3. Come down. Again, we'll clean this up. Might actually work. Surprisingly enough. I'm gonna fill it. That's actually fine. Three v three. All right, that looks like it'll connect just fine. All right. Not perfect, but it looks like it'll be fine. Then let's route off of this guy. And we'll drop via in right here. And we'll go from you. All right. Okay. So far, so good. We'll worry about getting some of this other stuff routed. So, all right, let's throw in a ground pour for this guy and tie it into here, and we'll do the same down here. Boom. Let's kind of go here to ground. This guy, we'll make sure. So that's a hole. Perfect, perfect. So we got a nice ground pour. All right. I know we've got the two staking points for the connector itself. That'll be grounded as well. That'll tie, but it never hurts to throw in an extra via. So let's go ahead and do the other. Let's just copy and do it down here. Ground, come over. Boom. And then ground. Now, okay, now this V bus needs to tie up to that V bus because since this is a USB-C connector, I know I could have went with like B micro, but and would have been a lot easier to route. But I like the USB-C because it's becoming more standard. There's no reason to go with it to not use it. So what we're going to do is we're going to kind of pull off here, drop a via. Oh, we may have to change how we do some things, but we'll figure it out. Like that little dog leg right there. Let's see. There we go. All right, back to top copper. All right. So we have this ground over here. Let's go get that guy. Poured in. Ground. Let's just throw it in with this guy. Throw it in here. We'll grab that via. We'll throw another via in there. See what you look like. Ground. All right. So got that. Ground connections. All right. Let's pull. Oh, you are not happy. Your clearance is not very happy. Okay. All right. Our design rules are... All right. Constraints. Minimum clearance. Okay, what are our minimum clearance rules here? 0.203. Let's see if that fixes it. Yes. What in the world? No. Okay, why in the world are you? There we go. And positive. All right, so there we go. We got some of that guy going there, some of that action. Now we got to figure out how we're going to tie our negatives, these two. So there's a couple ways we can go about doing this. One is, again, if this were an ultra high speed differential pair bus, I'd be more concerned about proper routing to get impedance, to do proper impedance matching of 120 ohms. But considering this is only used to program the ESP32, we're only talking about, 115,000 baud data stream. We're not talking, a high frequency bus in the megahertz or gigahertz range, like a memory chip or, something like that. You're wasting your time if you're going to be extremely retentive over getting that impedance matching. You will never get it. And for low speed data buses like this, it's a waste of time. You're basically putting effort into a battle you're never gonna win. Sometimes it's better just to make sure the signal gets from point A to point B as cleanly and neatly as possible, and just go from there. So what we're going to do then is to get that gets the positive. The USB data positive. And I've designed multiple USB interface chips. I've been using the same Silicon Labs chip with the same connector, following the same principle that I'm not going to spend 100 hours making sure differential pairs match impedance properly. I have multiple boards, no issues, none whatsoever. So that's where I stand with it. And I might get a lot of arguments, but really I don't care. All right. It does not like me putting a VIA there because the space is not. So, no, we're going to have to just kind of open you up a little bit. So what we do then is we route. We do the VIA here first. Done here. Drop the VA here. Then what we're going to do then is come here. Wrap ourselves around the VIA. Wouldn't want a VIA. I see ya. Wouldn't want a VIA. All right. So boom, there we go. Again, low speed data bus. We're not talking uber high speed to where this is going to cause a problem. No, I'm not going to spend a million hours just trying to make sure it's nice and clean. I won't. It's not worth the effort. So here we go. So we got V bus tied into here. So DP, DN. So there's no other ground here. This is just for this is a TVS for this guy. So let's kind of see. Can we route this guy up in here? Can we thread the needle, as it were? Looks like we can thread the needle. Looks like we've got enough clearance. And then DP. All right. All right. I don't know why you didn't just let me continue routing you, but hey, that's fine. Again, that's just a TVS diode. I'm not going to sit here and worry excessively over that. So let's get the ground connected. Let's throw in a ground pour right here. Ground pour. Control V. All right. Ground. All right. Kind of clean this guy up a little bit. All right. Beautiful, 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 beautiful. All right. So then I have the test points I want to route. Oh, can we thread the needle? Yes, we can. Let's see. All right. This test point. Kind of want to avoid that DTR pin in case I need to. Let's clean this up. There we go. And then V bus. That's going to be an interesting one. Now, since we're kind of already over here, most of this is already wired up. And we've got, so we got a through hole. And we've got a via for V bus. We're just going to go ahead and grab an internal layer and just route it there. No harm, no foul, and it just takes advantage of the fact that we've already got vias and internal layers and stuff, and we're on this side of the board, so we don't really have to worry about anything else coming over. We should be good. Because we're, like I said, we're on this edge of the board. We're pretty much done. That, okay, now we have ground, ground, and ground. So what I'm going to do, copy that, run through basically a VM pad there, VM pad there. Okay, and let's just grab this guy, route this guy into here. Are there any other ground pads? Okay, I don't like the fact that it threw you there. Let's... There we go. Let's make that a little bit beefier. There, that's fine. I mean, technically it's gonna, it might give me an error during DRC, but we'll find out. Okay. So that's this little guy wired in, plumbed in for the most part. All right, this side of the board, other than the core signal. Oh yeah, let's get this guy. It's just a pull up. ESP3 board. All right, these guys are tired. That's a test point to ground, so it's going to be on the ground plane. All right. No, really, one more major component to. Oh no. Let's finish these guys off here before I forget. Because what happens is I'll forget. Right, and then again. There we go. To the test points. Might as well tie them together here anyway because they're going to be tied in together anyhow. So let's look at the ESP32. Let's start figuring this guy out. And this is where some of the interesting fun's going to be. So, all right. So we're kind of like in a good position. I think it's fine where it is. So, ESP enable. Let's look at this ground. ESP enable. Okay. These capacitors are the filter caps for the power supply on this guy. So let's bring this guy up here. All right. So let's just say roughly there. Again, we'll tidy up all their locales once we get to that point. All right. These are the signal pull downs. We'll kind of put those closer to the pins that they belong to. All right. This is for the auto programming. Okay, so ESPEN. These are the resistors that support the auto programming. Let us see. Okay, so we're going to move him down here. That's the reason we're doing this up like this. You know, honestly, we do have enough room on top. Let's move this guy back to the top. Move this guy back up to the top. All right. Okay. So let's take care of this guy. Let's get the ground plane wired up. So what I'm not going to do is connect all these together in one big copper port. Instead, I'm going to make individual islands. The reason is that way I can kind of escape traces out from underneath the ESP32 this way, or whatever ways I can escape them. That way I don't have to use as many vias. So what I'm going to do is I'm going to make a copper pour for the central ground plane. Ground. Should have the big vias. What I will do So what I'll do is that. A couple more in the corners here. Make sure this guy is well grounded. All right. Push you up. Yeah, I'm not trying to. Okay. Fill that pad in. All right. So that gives us a nice solid ground connection there. So let's go ahead. Tie this guy in the ground. Kind of come this way. All right. The ground via in there. Ground via in there. Ground via there. That way we can avoid the silk screen. Let's go ahead and tag this guy with the copper pour as well. In there. All right. Okay, got our ground pours right there. Now let's concentrate on our 3v3. Sorry, I didn't catch that. We will rearrange these guys here in a minute to whatever suits best for our layout. So 3.3 and ground. These don't really have to be part of any of the major buses, but it's fine. This is just basically the delay circuitry to bringing up that. Let's see here. Let's get this guy centralized. 35.5 and 32.5. 32.5. All right, so we're matching the Y. Let's kind of go 77.5. 79. 79.5. All right. So let's kind of give ourselves a little bit more room. So we can throw some vias in there. Let's get these guys to match. Don't have to, but I like the symmetry. Okay. Kind of push you over a little bit. All right. Okay. So. All right. So let's get a copper pour in for the 3v3 here. Let's put you in right here. 3v3. Come down. Come over. Down. All the way up. Fill you in. Let's see how you look. All right. Go in. Vias. All right. Got some nice power vias there. Let's throw you in here. Boom. All right, I'll clean that up. There. Now, hopefully there's enough room to throw in a via right here. Okay. Here. There we go. Beautiful. I like it. I like what I've done with the place. These guys we can escape out this way if we have to. And this way, vias, whatever we have to do. Multi-layer if we need to. Not a big deal. We've got it going on. Oh, there's actually another little ground I missed there. Let's get that guy covered in real quick here. Ground. And then I'm saying something I missed in the design, and I can't believe I did that, but it's fine. We will take care of it in the next video. Just a little easy mistake. Oh, crap. Let's do that again. Must have dragged it the wrong way. Didn't connect the end. I'll fix that. Again, we will fix it. Oh. Okay, I'll zoom in. Ground. All right, let's just get this going. Yeah, so as I was trying to say before sometimes it's hard to talk and work at the same time. That tie in the ground. So, real quick, before I get too far ahead of myself, for the schematic, so if you look on the ESP32, I pulled out the UART for serial interface for basically like a FTDI cable. And I never put in the connector, the 6-pin header connector to tie to that. So we'll take care of that next, the next video. Can't believe I did that. We'll throw in the 6-pin connector, get it tied in, get it plugged and chugged. Throw some TVS protection on it as well, and get it into the design, onto the board. We got plenty of space, plenty of real estate, so I'm not terribly worried about overlooking that. That was my bad, my mistake. I can't. So yeah, we'll get that next video, next section. There we go. Biggen that a little bit. And let's just go ahead and fix this. Round. Boom. There we go. Got that ground. Let's make sure I'm not missing any other grounds. Can't believe I did that. Okay. All right. So the next major components for this guy are the auto program boot mode. So we have boot mode, which goes down to this pin, and ESP enable, which goes up to that pin. So we have the program control switches here. So let's kind of figure out a happy little home for the programming logic. Realistically, they could sit out here on top. We've got the room. Maybe, because we have these 4 test points we want to make sure we throw in here. So it might be better just to leave them underneath the ESP32. So next video, we will add the missing component. Can't believe I did that. And we'll continue on with the routing. We're pretty close to being done with the routing. Not a whole lot more to go. I mean, it seems like there is, but there really isn't. It shouldn't take long to figure out the signal cables, the signal lines from the ESP32 to all the inputs and outputs. That won't take long at all to figure all that out. The bulk of the power connections are made. Now that those are done, things should go a little bit easier, be a little bit better. Now that those are solved. So I thank you for watching. Thank you for checking us out. And I will catch you in the next video. Have a nice rest of your evening.